much, Caitlin. So we are going to look at multiple transformations. Today we're starting with just the basics. So we're going to start with one type of transformation that we could see. And the way that this happens is we adjust parent function equations. So the first thing we have to be able to do is to recognize these function family equations, or the parent function equations. Now, we looked at this last week, but we're going to do a quick recap just to make sure everyone is on the same page. So on frame 4, we have multiple function family names. Now, let me just draw a quick kind of drawing of each of these function families so you guys can kind of hopefully jog your memories here a little bit. And then we will get to matching these names with the proper equations. All right, and I'm going to call on some people. I'll ask for some volunteers first, see how we're doing. So this x, let's think about, where would I move this x? What equation is described by that x? Which function family would this belong to? Let's see if anybody remembers. This was in our notes that we did last week. It's in that digital notebook if you need to pull that up. Where would x, what equation, what family does that go with? Where should I move this Post-it to? Anybody? Oh, I deleted it. There we go. Yes, thank you. This is the linear equation. So linear is just an x. So if you see just an x in an equation, you're going to know that the parent function, where it starts from, where it originates from, it's kind of like perfect situation as if it's just x. It's going to look like this linear function. We're going to have a straight line situation. Okay, let's try a trickier one. Or let's see if somebody can just give me one. Finn, can you give me, let me number these. Let's say this is 1, 2, 3, 4, and 5. Finn, can you tell me a number and which function family you think it belongs with? Again, this is review, so we're just going back to what we did last week. Give me a number and which function family you think it belongs with, Finn. 4 is absolute value. Yeah, good call. So I'm going to move that one over here. I'm going to move this x to the power of 2 over to quadratic. That is one that we did last unit. So now I'm left with 1, 2, and 3. Let's see. Does anybody know where 3 would go? This a to the power of x. It wouldn't let me do exponents, but you guys know, you can get the gist of it. Where do you think 3 would go? This a to the power of x. If you had to take a guess, just throw it in the chat if you think you know. We got 3 left. Yes, this is an exponential function. So if these are things you're not remembering, now could be a good time to just jot it down quickly. And then we have 2 left. These ones get mixed up quite often. Again, this is a situation where it wouldn't let me do a square root sign on a Post-it. So this SQRT means square root. I'm going to move that one to our radical family. And this 1 over x is going to go to rational. Now, if you are not familiar with these, you're going to want to get familiar with these. So go back to those notes, practice, ask questions. Couple easy ways to remember this. If you see something that looks like a ratio, guess what? It belongs in the rational family. If you see something that has a variable in the exponent, it's exponential. Okay, absolute value, hopefully that's a gimme for you guys. But yeah, go back through, make sure you recognize these. What we're going to do is we're going to use these equations. We're going to change them a little bit. We're going to add things to them, and that's going to tell us how we can move them on the graph. So let me get to our first. This is new stuff. Here we go. So make sure you are following along with me. This type of transformation is what we call a translation. And you're going to talk about that more in geometry. Translation is the fancy math word for sliding. So we're basically taking a graph. We're not like stretching it or, shrinking it. We're not changing the shape of it. We're just literally sliding it around the coordinate plane. Oh, good, Caitlin, then you should be a pro. All right, so what's happening is I have over here, this will be when I take the original function. So I take those original parent functions that I saw on the last slide, and I add a number. I want to know what it means. What's it going to do on the graph when I add a number? What's going to happen is I'm going to move up that many units. So if you see plus something, you know that we're going to move up that many times. I'm not going to change the graph. I'm just going to move it up. So then if I subtract a number, what do you think I'm going to do? Which way am I going to move? When I add a number, I moved up. When I subtract a number, what do you think I'm going to do? Yes, thank you. We are going to move down. All right. So let's switch on over to these two examples over here. Let's look at this top one. The blue represents our original function. This is where we started. And I want to know, how have we changed it? So we can see that we've moved it up, definitely. I want to know how many times I've moved up. All I have to do is count. So I can see, oh, 1, 2, 3, 4 times I've moved up. That means I would add 4 to my equation. Since this is a quadratic function, my overall equation would be y equals this f of x. I can fill in with that parent function of a quadratic. It'd be x squared plus 4. Right? Then I'm going to look at this second example. So again, the blue is where I started. The red is where I moved to. And you can see that I have moved down. I haven't changed the shape of the quadratic at all. It's still the same graph. I've just slid it around this coordinate plane. And since I've moved it down, we can see I would subtract a number. And I've moved it down 1, 2, 3, 4, 5 places. So that means I would be subtracting 5. Again, since this is a quadratic function, my equation for this, I'd fill in this f of x with that parent function, and I would say y equals, this would be x squared minus 5. All right, I'm going to pause. Let's get a scale of 1 to 5. 1 being I don't understand, 5 being I think I got it. Let's see how you guys are feeling. Throw it in the chat. Now is also a great time for questions if you have them. Thank you, Connor. Thank you, Caitlin. We're just sliding things up and down. Still need to hear from Shar, Damari, Gabrielle, Finn, and Bailey. Thank you, Gabrielle. Thank you, Shar. Thank you, Finn. All right, it looks like we have 5s all around, so I'm going to guess that we don't have any questions. So let's move on to this example. I'm going to move on to frame 6 of my Jamboard if you're on there. So frame 6, we have a different looking graph. This is a different parent function. And this time I'm giving you the equations, and I want to try and change my graph based on that. So what I'm going to ask you guys to do, I'm going to give you about a minute, and I want you to tell me, here is where I'm starting with. I'm starting with this absolute value function. I want you to tell me if we're moving up or down for each one of these equations. I'll call this one A, this one B, and this one C. I want you to tell me if we're moving up or down and how much we're moving up or down, and then I'm going to call on some people. So I'll give you about 40-ish seconds here. And be ready with some answers. All right, you can see I put some names above each of those. So Connor, you're going to tell me how this first one moved. Gabrielle, you're going to tell me how B has moved. And Damari, you're going to tell me how C has moved. You can either type it in the chat, or I would love to hear your voices if you want to unmute. Let's start with Connor. Connor, how has this first one moved? What is happening? Is it going up or down, and by how much? It moved up 5. Yeah. So what I would do, I'm going to take my green pen, and you guys, if you're at home, you can just label it A, B, and C. I'm literally going to count. I'm going to take this middle point, and I'm just going to move it up 1, 2, 3, 4, 5. Put a dot there. And then I can draw my same absolute value function. That has not changed. It's still just a V. I've just literally taken it and slid it up. And I'm going to mark this as A. Awesome. If at any point you're confused, raise your hand. Gabrielle, you're next. Gabrielle, tell me, how is this one moved? Down 2. Yep. So I'm going to write that down here so I remember. I should have written up 5. So this means I'm going to take this middle point and I'm going to move it down 1, 2. I'm going to put my middle dot there. And then again, I'm just drawing this absolute value function. That has not changed. I'm going to put my arrows on because it keeps going on forever and ever. It's just a V. All right. And then Damari, your last. Damari, how is this last function moving? We are moving up. Can I ask, where'd you get the 1 from, though? We're moving up because we're adding, but how much did we add? You're close. I think you're looking on the last frame. I think you went, did you go to this last one? Maybe? These are separate problems. So I think maybe you were either combining this or looking on our last frame. This is a separate graph. So we're only looking at this +3. I think you have the right idea. This is just an absolute value sign. So don't overthink that. Here, we're adding 3. So this is going to tell us, Damari, to move up 3. Does that make sense? There we go. You got it. So here I would just move up 1, 2, 3. Again, I put my dot in the middle, and then I'm just going to draw my absolute value. All right? Mine's a little bit off, but you guys get the idea. So what we've done is we take these parent functions and we moved them around. All right, I'm going to pause in case we have a question. Don't be afraid to ask. This will be on the quiz on Friday. All right, now it doesn't always have to be an absolute value. Let's look at one last slide. I'm not going to do all of these, but I just wanted to show you guys that it could be something else. So on frame 7, for example, here I don't have this absolute value equation anymore. Instead, I have the square root. So the square root tells me that this is the radical function family, and the radical function family looks like this. However, I'm going to do the same exact thing. Nothing's going to change. I'm going to still say, how has this moved? What am I going to do with it? For example, this first one, let's say this was A. Let's say this was A. This +2 would tell me to move up 2. So I would take this middle point. I would go up 1, 2. Put my new dot there, and again, I would have this square root function. And it's not a perfect sketch, but all I've done is I've taken this little arch, I've moved it up 2 spots. I haven't changed the function itself. I've just moved it around the coordinate plane. All right, are there any questions? Let's get one more, 1 through 5. So 1 being, I'm lost, 5 being, yeah, I can do this. Throw it in the chat. Thank you so much, Caitlin. Thank you so much, Shar. Thank you, Connor. As the rest of us are getting our ratings in, or questions, if you have them, I would love to help you answer them. I just want to remind you, tomorrow, your assignment, if you go to Google Classroom, you have a Delta Math. You can actually even start it today if you want. There are some that do not have penalties. There are some that do, and that will be due on Thursday. That's our cue, guys. If you heard the bell, it was wonderful working with you today. Have a great rest of your day, and I'll see you on Wednesday. Oh, don't forget, you can upload these to your digital notebook. Bye. Thanks, you too, Caitlin. sorting.